Okay, so in this series, we'll talk about how you will be building the simple line following robot. So the main components are we have your line sensor. So maybe most of you may use this one. This is a 3 channel line tracking sensor. What is installed here is a 5 channel, but later on we'll just be using the 3 channels of this one. So the line tracking sensor, we have your chassis, we have your 2 motors, DC geared motors that has rubber wheels. So this is our main board. We have your microcontroller and we have your motor driver. So this is your STC microcontroller, which is an 8051 base high performance microcontroller from STC. And this is a BP6612FNG microcontroller, which is a compact, a motor driver, which is a compact motor driver in this form factor. So the very important one is you have your power source. So for this uh, version, I am using a lithium ion battery. So like this one, this is a single cell 2200 mAh lithium ion battery, and it's connected in series through a battery management system, and it is charged using this charging module. So this is charged as 12 volts, and since this is 8.4, so the 8.4 volts coming from this series batteries is connected to the V in of the regulator and the V motor. And we have your power switch. So now, how is this connected? Okay, so by the way, you can use this one, double A battery, 6 volts. So I don't have batteries right now for your motor, and 9 volts for the logic. Okay, so how we also have here your USB to UART for programming the microcontroller. Okay, so how it is connected. So now we have, I have here 2 screw terminals. So as you can see here, I have here this one. So these 2 screw terminals are for connecting to the power source. Okay, so then I have your V motor. So I have a diode. You can see here I have a small diode. So for uh, protecting your microcontroller and the regulator for reverse input of battery. So when you put your battery and you accidentally reverse the connection, then it will be safe. No parts will be hurt. Okay. So now we have your 7805 regulator to convert your 9 volts or 8.4 volts to 5 volts, which will be going to the VCC of your microcontroller. Okay, so at the output of the regulator is typically I use a 100 microfarad capacitor. So for this one, it's 100 microfarad capacitor. And for the motor driver, so this is your motor driver. Okay, so the connections for this motor driver are, we have your connections for the motor, which is two terminals or terminal block, which is this one. and you have your VM going to vMotor. So this is where you will be connecting your 6 volts battery. So separate battery for the motors. And the VCC is connected to your 5 volts. Okay, so the connection for this one is typically, it can be used also for L298 and L293D. Okay, so the standby of this motor driver goes to 5 volts. Okay, so if we take a look at L298, so L298, and we have L293. So these are common motor drivers. So as you can see, we have VCC1 and VCC2. So this VCC1 and VCC2 corresponds to your VM and VCC here, and your VSS and VS here corresponds also to your VM and VCC. Just take a look at the datasheet where you will be connecting your vMotor. So enable is, these are your PWM-A and PWM-B pins on the TB6612. So it is connected to the microcontroller so that we could enable or disable the motors, or we could control its uh, speed. So basically the same for L293, you have your enable pins. And the input pins in 1, in 2 here, 1A, 1, 2, 3, 4A, in 1, in 2, in 4 here. So is equivalent to your A in 1, A in 2, A, B in 1, and B in 2 here, which will be used to control for the direction of the motors. Okay, so that is for the motor driver. Now, for this particular hardware, my connection for the A in 1, A in 2, B in 1, and B in 2 is connected to 1.4 to 1.7. So these are the pins that will be used to control the direction of the motor as well as the braking. So as you can see here, I have connected a switch. So a general purpose switch, which can be used uh, for whatever reasons. Like if you want that I will press the switch before starting the main program, then we can do that. So that's why I added here connected to P00 of our microcontroller. And for the sensors, as you can see here, for the 3 channel, we have your VCC, left, center, right, and ground. So in this particular hardware, I am using port 2 of the microcontroller to this port 2 is where the sensors are connected. So since we are just using 3, so it's connected to 20, 21, and 22. So for easier uh, programming. And we have your 5 volts and ground. Okay, so this header will be connected. Okay, wait, so this header will be connected to your sensors. Okay, now since this microcontroller needs USB to UART for programming, okay, so this one is where uh, this pin header, this is where you will connect your USB to UART. Okay, so this is just the basic connection of your uh, board, your microcontroller, the sensors, the motor drivers, and the battery source. So to take a look, From this schematic, then you can just create the PCB. So for your requirement, you are required to create the PCB. But for me, I'll just be using just general purpose PCB. Okay, so I'll just import the netlist. Okay, so as you can see here, this is my microcontroller. This is my motor driver. Okay, so this is my switch. This is the pin header for the UART. So I have here my voltage regulator for 5 volts, and this 100 nanofarad capacitor should be placed near the VCC and ground of your microcontroller. Okay, so I have your reverse protection diode. I have your screw terminal for uh, the 9 volts battery, or it can be connected in parallel with the motor input if you are using a lithium ion rechargeable battery. And sensors. So basically, it's just a pin header. I just locate it here, and the headers for your UART. Then you have your motor A and motor B. So basically, this is your main board that you will be etching. So it would will usually will look like this. So you have this is where your microcontroller will go, your switch, the regulator, so your screw terminals and pin headers where you connect your sensor and your UART. Okay, so here I have my pin header here for the UART. Okay, so now you have your hardware. So you can now start to program your Mobot. Okay, so by the way, you could also use single rechargeable lithium ion battery, but still you need a charging module and a DC to DC converter to a increase the voltage coming from this lithium ion battery, because this is just 4.8 4.2 volts. Okay, so the next series we'll be talking about we'll be testing our motors.